Hey, this is Math 6, Unit 4, Lesson 2, Meanings of Division. And we're going to talk about ways to think about division today. So here's an expression, 20 divided by 4. And what are some ways to think about this expression? Describe at least two meanings you think it could have. So looking at 20 divided by 4, what do you think that actually means? Okay, so you're talking about, having some numbers here and dividing those numbers up, right? So perhaps with division, depending on what you maybe learned from prior grades, you might think about this as being, how many groups you turn something into. Maybe we're taking 20 and putting that into 4 groups. Or you could also maybe think about it as how many are in each group. A couple different ways you might consider that, right? So if you have something like 20 here, this might be how many groups of 4 are in 20, or how many are in each group if we split 20 into 4 groups, right? How many would be in there? How many 4s are in 20, or maybe what times 4 equals 20. There's lots of different ways you might think about this expression, and that's okay. That's kind of the fun part about playing with numbers and how those work together. But let's take a look at some real examples here. And we're going to look at bags of almonds first of all. It says that a baker has 12 pounds of almonds, and she puts them in bags so that each bag has the same weight. So the bags are all the same. So she's taking those 12 pounds and she's putting them into different bags, right? The bags of almonds, whatever it's going to be. So it says Claire and Tyler drew diagrams and wrote equations to show how they were thinking about 12 divided by 6. Alright, so here's 12 divided by 6 for this one, and we can see we're taking the 12 and we're putting it with 6 here. Maybe this is a bag. Maybe this is a bag and this is a bag. Maybe, okay. And here's 12 divided by 6, and they went ahead and broke it up as to, Tyler does it with this one, and Tyler does the 6 and says, well, I have groups of 2, so maybe these are each going to be bags. I'm not really sure, right? So Claire's diagram has something times 6 equals 12, and Tyler has 6 times something equals 12. How do you think Claire and Tyler thought about 12 divided by 6, and explain what each diagram and each part of each equation, especially the missing number, might mean in the context of the bags of almonds? Okay, so here we have Claire. She has 12, and she's taking the 12 and she's breaking it up into, we can see, groups of 6, right, that have a value of 6. So in this case here, we can see she's making, in our case for the blank missing value, she's making 2 bags. And what Claire's saying is that if you take the 12 pounds, you can make 2 different bags that have a value or a weight of 6 pounds. This is 12 pounds, and so if you break that up, you end up with 2 6-pound bags, is what she's showing with her picture here. Tyler does something a little different, and Tyler takes the 12 and decides that this number 6 is going to be equal to the number of bags. So in his case here, the 6 equals the number of bags, and in her case, the 6 equals the pounds in a bag. Alright, so in this case, this missing number is 2, and that 2 represents the number of pounds they're going to be in each one of the bags. Are they thinking differently? Yes, in a sense, but they end up with the same 3 numbers working together as part of their expressions. That's 6 divided by 12 divided by 6, and it can be seen a couple different ways. Either this is going to be how many go into each group if the value of the group is 6, or how many groups can you make if you're gonna, or how much goes into it if you're gonna make 6 groups. So different ways of explaining it is kind of the cool part about division. Alright, so you might have a disagreement with somebody about what's happening 12 divided by 6, but the idea is, can you explain what do you see happening there? Let's take a look at some more examples. So explain what each division expression could mean in the context of the bags of almonds. Then draw a diagram and write a multiplication equation to show how you're thinking about the expression. So when you think about 12 divided by 4, again, this 4 could be the number of pounds, lbs, that are in each bag, or it could be the number of bags, right? Depends on how you think about that. So I could draw a picture like this and say, all right, this is 12. And if I want to break it up into 4 groups, 1, 2, 3, 4, right? 1, 2, 3, 4, like so. And then I'm saying if I'm going to take this this becomes my bags, how much goes in each bag? Right? That's going to be 4 times some number is going to equal 12. And in this case here, we would say that would be 3. So we'd have a value of 3 in each bag. Now that's one way of thinking about it. The other way, which is just as acceptable, is to draw a little diagram like this. And we're going to say that, well, what number times 4 can get you to 12? So if we're going to make each of our bags have a weight of 4 pounds, if that's 4 pounds, then I need to make that division here, and I'm going to say that in this case here, each one has 4, so the number of bags I end up with here in this case is going to be 3 bags. All right, so both pictures work, depends on what you're doing here. In this case, I have 12 being broken up into 3 bags with 4 pounds apiece. Here I have the 12 pounds being broken up into 4 bags that each weigh 3 pounds apiece. So it depends on which way you want to go. Do you want to worry about the 4? Is the 4 going to be representing the number of bags you're breaking it up into, or is 4 represent the number of pounds? This is kind of the bag way, right? 4 bags, and this is the pound way, 4 pounds. We can do the same with 12 divided by 2, right? We can take our 12, and we can say, well, let's break that up into, in this case here, if it's bags, we break this up into 2 bags. So we'd go 2 like this, bag 1 and bag 2, and we're saying, all right, I have 2 bags times the pounds equals 12. And in this case here, we would say that's going to be 6. So the pounds would be 6. If I do the other one, we have 12 there. We know that we want to know how many pounds or how many bags we'll take if we're going to do 2 pounds in a bag. All right, this is bags. And we would do 6 again. So we're going to go with 1, 2, 3, 4, 5, and 6 total. And so we'd end up with 6 bags. 1, 2, 3, 4, 5, 6. And they each have a value of 2 pounds. When we do the half is a little bit different, right? So it's, in this case here, it's how many pounds in a bag if there's 12 pounds in half a bag. So it does say also to draw a diagram, multiplication. Okay, so in this case, we have 12 again. Okay, so there's our 12. And over here, we were thinking about, okay, if this is going to be, let's say this is going to be pounds. Let's do pounds real quick, LBS. So pounds. I'm going to divide 12 into half-pound bags. So how many bags do I need times a half a pound to get to 12 pounds total? That's the idea. How many bags am I going to need if each bag is half a pound to get me up to 12 pounds? So let's take, for example, 12. And if I had 6 bags, let's make them 6 real quick. 1, 2, 3, 4, 5, 6 bags. If I had 6 bags and each bag was 1 pound, 1, 1, 1, 1, 1, 1, I would have 6 pounds, right? If each bag was 6 bags, 1 pound apiece, we're there. So if I have 2 pounds in a bag and 6 bags, now I'm at 12 pounds. But I want to make these into half-pound bags, right? So that's not going to help me out too much. So let's extend this out here. 1, 2, 3, 4, 5, and let's make 12 1-pound bags first of all. Let's draw a picture of that. So if I draw a picture of 12 1-pound bags, right, where they're all 1-pounders, something like that, this is 12 1-pound bags. But I want to make a half-pound bag, which means I'm going to take my 12 bags, which I have here, and I need to divide each bag into half, right? A half, a half, a half, a half, a half, in order to make a half-pound bag. This means that I have a half-pound bag here and a half-pound bag there, and so on all the way through, which gives me a total of 24 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24 bags. So I can actually have 24 half-pound bags, and that's how I would distribute 12 bags of almonds. All right? So it's kind of a little bit more complicated, but you can draw a visual for that. My visual may not be the best. Your teacher may have a different way of showing that. I have to think about it for a little bit before I do it, and even as I started today, I second-guessed myself, but it does work out. So let's look at the Are You Ready for More real quick. You have a loaf of bread, and it's cut into slices. So here's our loaf of bread. If each slice is half a loaf, how many slices are there? So if a slice is half the loaf, we end up with 2 slices. If a slice is 1/5 of a loaf, so 1, 2, 3, 4, then how many slices are there? We end up with 5 slices. What happens to the number of slices as each slice gets smaller? Well, the number of slices is going to increase, right? The more slices we make, as the small slices get smaller, we end up with more slices. It increases. Interpret the meaning of dividing by 0 in the context of slicing bread. So if we have our bread and we cut it into 0 slices, what does that mean? It doesn't mean anything. It's just a loaf of bread. So that's actually the idea there, is that dividing by 0 just doesn't make any sense at all. All right, take a quick look at your lesson summary. All right, here we go. Suppose 24 bagels are being distributed in boxes. The expression 24 divided by 3 could be understood in 2 ways. We can think of it as 24 bagels are distributed equally into 3 boxes, right? So there's our box 1, our box 2, and our box 3. Or we can think about 24 bagels distributed in 2 boxes, and there's 3 bagels in a box, right? So there's 3 in each box. This ends up with 1, 2, 3, 4, 5, 6, 7, 8 boxes. Okay, so there's both interpretations. In both ones, the quotient is the same. 24 divided by 3 is 8, but it has a different meaning in each case. In the first case, the 8 represents the number of bagels, right? So this 8 is the number of bagels. But over here, in the second one, the 8 represents the number of boxes. These 2 ways of seeing division are related to how 3, 8, and 24 are related in multiplication. Both 3 times 8 and 8 times 3 equal 24. So you can read it as 3 groups of 8 make 24, and you can also read 8 groups of 3 make 24. If 3 and 24 are the only numbers given, the multiplication equation would be 3 times something is 24, or something times 3 is 24. In both cases, the division of 24 divided by 3 can be used to find the value of question mark, well, we don't know, but now we see that it can be interpreted in more than one way. And that's kind of the key thing here. It can be interpreted more than one way. So the question mark can be the size of a group, or it can be the number of groups. Those are 2 things that it could be. It could be the size of a group. It could also be the number of groups. So just keep that in mind as you're working through the problems on today's activity, and just make sure you have an understanding of what you think you're doing there. Okay, we'll pause there, let you work on your homework, and come back together in a moment. All right, homework time for lesson 2. 20 pounds of strawberries are being shared equally by a group of friends. The equation 20 divided by 5 equals 4 represents the division of strawberries. If the 5 represents the number of people, what does the 4 represent? Okay, so we know that the 20 are the total strawberries, right? The 20 pounds of strawberries is the 20. That's good there. So if the 5 here happens to be the people in the 5, then the 4 is going to represent how many strawberries each person gets. Okay? But if the 5 represents the pounds of strawberries per person, what does the 4 represent? In that case here, that would be the 4 is the number of people. Okay? So the 4 could be the strawberries or it could be the people, depending upon what the 5 is going to be. The 20 stays the same each time. All right, number 2. The 6th grade science club needs $180 to pay for the tickets to a science museum. All tickets cost the same amount. What could 180 divided by 15 mean in this context? Okay, so we know that that's the total amount they need is 180. So the question is, what does the 15 mean? So 15 could be the cost per ticket, right? So it could be that each ticket costs 15, or it could be the number of students, right? So if I have $180 and it's $15 per ticket, I could find out how many tickets I could buy if it's $15 each. Or if I have 15 kids, I could find out how much the ticket's going to cost if I have $180 and it works for 15 kids. Either way, you end up with 12 as being the quotient. So either the cost per ticket is 12, right? Or I'm taking 12 students. Okay, so think of it this way. I could do 12 students times $15 each equals $180 total. Or I could do $12 tickets times 15 students, but also equal $180. You see, my number that I'm working, my total ends up being the same, but that number, 15, can be the cost per ticket, or it can be the number of tickets, but that also changes what the 12 means as well. Okay? Number 3. Write a multiplication equation that corresponds to each division equation. All right, so 10 divided by 5 equals question mark. So we could say question mark times 5 equals 10. Over here we could do question mark times 3 equals 4.5. And here we do question mark times 4 equals a half. All right, and then that's what we could do. You don't have to solve it that I'm aware of, but you could solve if you chose to, and that's just fine. Number 4, write a division or multiplication equation that represents each situation. Use question mark for the unknown quantity. So 2.5 gallons of water are poured into 2.5 gallons into 5 equally sized bottles. How much water is in each bottle? So we're taking 2.5 gallons and we're pouring it into, so we're dividing it up into 5 equal bottles, and the question is how much is in each bottle. That's one way of thinking about it. Here, a large bucket of 200 golf balls is divided into 4 smaller buckets. How many golf balls are in each bucket? So 200 golf balls is divided into 4 buckets. How much is in each bucket? Alright, 16 socks are put into pairs. Pairs are 2. How many pairs are there? So 16 socks are divided into groups of 2. How many are there? Alright, again, that's just one way of thinking about it. There's others. For number 5, it says find the value for A that makes each statement true. Alright, so we want a number here where 6 is going to be, something divided by 6 is greater than 1. For it to be greater than 1, then this number needs to be bigger, so A has to be greater than 7. Anything greater than 7 would work, because it has to be a bigger number than that one. If we want it to be equal to 1, we would say A is going to be equal to 6. If we want it to be less than 1, then we pick any number less than 6. Or, well, less than 6, less than 6. Yeah, so 5 works, 4 works. And if it's equal to a whole number, it needs to be a multiple of 6. And that's a good question. For it to be a whole number, you could do like 12 divided by 6, right? That's 2. 24 divided by 6, it's going to be 4. As long as it's a multiple of 6, it's going to work out to be a whole number. Number 6, let's complete the table here. And we have percentages, decimals, fractions. So We show 1/4 is 0.25, and 0.25 as a percentage is 25% of 1 whole. This 0.1 is going to be like 0.10, and we can see if that's moving 2 places over, this becomes a 10% of 1. And as a fraction, 1/10 is 1/10. Here we have 75%, so as a decimal that's 0.75 or 0.75. And as a fraction, you could write it as 75/100, but that would reduce, of course, down to 3/4. 1/5. 1/5 is one you may kind of, have in your mind as what a decimal is going to be there. If I multiplied it by, 1/5 as a decimal, let's just leave it here, is 0.20. Okay, as a percentage, we're going to hop over 2 places, and that makes it 20%. This decimal, as a percentage, we hop over 2 places, becomes 150%. And as a fraction, we have 1.5, which is 1.5, right? Because 0.5 is a half of 1, so it's 1.5, or you could write that as 3/2. Okay, think of it this way. It's also 150/100. And then finally, this last one here, 140% as a decimal, move back that way 2 spots, becomes 1.4. Then as a fraction, that's like 140/100, which becomes 14/10, and then 2 goes in there 7 times, and 2 goes in there 5 times, or 7/5, because 14 divided by 10 can reduce to 7/5 there. All right, and then number 7, our last one. Jada walks at a speed of 3 miles per hour. Elena walks at a speed of 2.8 miles per hour. If they both begin walking along a walking trail at the same time, how much farther will Jada walk after 3 hours? Okay, so here's Jada, and Jada goes 3 miles every hour, and she does it for 3 hours, so that's 9. And then for Elena, she goes 2.8 miles, and she does that for 3 hours, so that's going to give her a total of 8.4. And in terms of who goes more, we know Jada goes more, but how much more? We'll do 9.0 minus 8.4 to find out that she goes 0.6 miles further, because she's walking a little bit faster. All right, that's it for today. Have a great day, and we'll see you next time.